Alright, welcome back to the channel. Today we're going to be making another carbon fiber part. This is going to be a Spur Gear holder plate for a Tamiya 415 Marc Rheinard style center shaft. It's going to look a little bit like this. This is the Tamiya part here that has been since discontinued. So we're just going to draw it up real quick and we'll see it out on the router. Alright, here we go. We have a new file in Fusion 360 here. We're going to start a sketch. Choose our plane. We're going to start out with a couple of circles here. The outside diameter of this part is going to be 23 millimeters. And we're going to get another circle here and put the hole for the center shaft, which is going to be 9.65 in this case. As you can see in the picture, this part is secured to the front of the spur gear. Actually pinches the spur gear on to the center shaft with 4 screws. So we're going to need to get those 4 holes into this part. And the way we're going to do that is we're going to put a center line on the part. We want it to be matching our outer circle. We're going to change that to a center line. And then we're going to constrain it to the center of the part by using the midpoint constraint. Next, we're going to place where we want our hole to be here. Of course, it's going to be a 3 millimeter hole, 3 millimeter screw. And it will be countersunk, so we'll get into that in a moment. And I've already measured the Spur Gear center shaft holder, and we came up with a dimension of 8 millimeters from center. Okay, and believe it or not, that's all the sketching that we actually need to do for this part. It's actually a very quick part to design. Of course, I know we don't have our other 3 mounting holes, but we will in a moment. We're going to actually use the 3D pattern tool to create all that. But first, we're going to finish the sketch. Change back to home view. For no specific reason other than I just like to extrude in this view. And we're going to go ahead and extrude this part. I like to extrude down. It keeps my sketch at the top of the part, which makes it easier to manipulate later if we need to. So we're going to go minus 2.5 millimeters on our extrude. We are making a new body over here. The direction and profile plane and all that looks good, so we will hit OK. Okay, so now we have our circular part and we have a hole in it, but it's not countersunk, so we're going to need to do that. And the way we're going to do that is we're going to use the hole tool. Okay, now we need to pick the face that we want our hole to begin on. And then we'll pick the circle to locate this hole. We're going to come over here to the dialog box. We're going to say we want the hole to extend all the way through the part. Hole type is going to be countersink. It is going to be a clearance hole. And we want to make sure, in this case, since it is a metric car, we're going to make sure that we have ANSI metric M profile. We are going to use a flathead machine screw. It is going to be a metric 3, and the fit is always going to be close. We always want to do close in ready control car applications because we want the holes to be as tight as possible. Hit OK, and we end up with a nice countersunk hole in our part. Now, of course, we still need our other holes. So we're going to switch to the top view. And then we're going to use our pattern tool, solid pattern tool. Now, of course, that's the rectangular pattern tool. We actually want to do circular. So you can change it here in the dialog box, or you can use the create drop down. And you can then choose pattern and circular pattern. Okay, if you notice, if I try to pick the whole part lights up. I'm actually going to switch back to the ISO view. The whole part lights up, and we don't want to do that because we don't want to pattern the entire part. We just want to pattern the hole, and the hole is considered a feature. So we got to come over here to the object type, and we got to change that to features. Now when we go to objects, we can pick the hole by itself versus the rest of the part. So we will do that. And then now we will pick our axis, which in this case, since we have modeled the part on the XY plane, we're going to pick our Z axis, which is going to revolve our parts around it, copying the hole that we've already done in however as many places as we specify. You can specify in this little quick box here, or you can come over here to the dialog and click 4. Okay, and we'll click OK. And that's actually our completed part. We will then save this part, and we'll do some tool pathing, and then we'll get it to the CNC router, and we'll cut one as a test piece, and we'll see how it fits up. In a future video, we will cover more on the cam tool pathing and the machining process, but I need to get some cameras and things sorted out before I can really show you what's going on with the CNC machine. So we will do that. It'll just be at some point in the future. But for now, that's our part designed for prototyping here, and we'll go ahead and make one, and we'll see how that works in a future video. Thanks.